Dr. P. Usha Rani, Professor RMT Engineering College. I am going to brief about the topic of full wave rectifier. In this, we have two types: center tapped transformer as well as bridge configuration. The drawback of half wave rectifier is there is a power loss because we are using only one half cycle. The other half cycle, the diode gets blocked. So the efficiency will be only 40.6%. We can't use the half wave rectifier for applications because we need a smooth and steady DC output. So we are going for full wave rectifier. Full wave rectifier converts both halves of each cycle of alternating waveform into a pulsating DC signal. That means it converts both positive as well as negative half cycles of an AC waveform. How you are achieving this is using a group of diodes. Generally, diode permits current in only one direction and blocks the current in the other direction. What is a rectifier? It converts AC into DC current. So I have taken first a center tapped full wave rectifier configuration. This is a normal two winding transformer only one slight modification. Here we have taken additional wire at the middle of the secondary winding. So this type of configuration divides the AC voltage into half, that is two equal and a half opposite voltages will be appeared in the secondary side. Suppose I have taken V input as this, so in the secondary side if you take R, that is half equal and opposite values of voltages available in the secondary side. So this is the configuration. We have taken AC input supply and center tapped transformer. Two diodes are connected, D1, D2 and load. So positive half cycle, if I am considering only the positive half cycle of the input voltage, the center tapped transformer, the upper one is positive potential and the lower one is negative potential, and the middle is actually zero potential. That is center tapped as zero potential. So this is positive potential. So diode D1 leads to forward bias condition. It acts as a closed switch. So I have mentioned that as closed switch. And here the lower terminal as negative potential. So the diode D2 has reverse bias condition. So no current flows through that. It has an open circuit. So the current flows through the diode D1 through the load. It has to come to the center point of, that is the zero potential point. So whatever voltage we are applying here, the half of the voltages we are getting the output. That is during positive half cycle. That waveform I have shown. So only diode D1 conducts, it acts as a closed switch. So current flows through the diode D1 and the load and the zero potential point, center tap point. This will act as an open switch D2. For negative half cycle, that is the input voltage taken as negative part of the input voltage. So here the lower terminal of the secondary one positive potential and the upper terminal as negative potential, middle, that is the center tap as zero potential. So due to the positive potential in the lower terminal, diode D2 is in forward bias condition. So it acts as a closed switch. So this must be in a closed condition. So current flows through that path. through the load resistor it comes to zero potential. Due to negative potential at the upper terminal of the secondary winding, diode D1 reverse bias condition, there won't be any current flows through that. So the output voltages during the period of that is negative half cycle, so T by 2 to T period, the output voltage waveform as we are getting sine shape. So during positive half cycle, both I have explained now. During positive half cycle, diode D1 conducts, I am getting the positive voltage, and during negative half cycle, D2 conducts, getting the voltage, both in the positive half side only. So this is the final output voltage waveform. Here there are some drawbacks in the center trapped transformer. One is there is only PIV, peak inverse voltage, is 2 times input voltage. So if the PIV coming across each diode is double, that means the maximum voltage across the half of the secondary winding. And another point is transformer utilization factor is 0.692, which will be higher in case of bridge configuration, which is 0.816, and the PIV for bridge configuration is only V, not 2 times. So the diode used in the, we are using 4 diodes in the full bridge configuration, which is capable of bearing the high peak inverse voltage. So we are going for bridge configuration. For bridge configuration, we have taken 4 diodes are used, D1, D2, D3, D4. We are giving the input AC voltage. So during positive half cycle, 2 diodes conducts at a time, D1 and D2 through the load. During negative half cycle, diode D4 and D3 conducts. So I am going for the mode operations. So I am taken the input supply as during positive half cycle. So during positive half cycle, the diode D1 will be in, that is the upper terminal of the secondary winding as positive terminal and the lower terminal as negative. So due to that, diode D1 and D2 will be in forward bias condition. So current flows through the diode D1 through the load and the diode D2, and it comes to the negative part of the secondary winding. That I have shown here. These two diodes act as a closed switch. So I have shown this diode D1 as a closed switch through the load. Current flows through diode D2 and it comes to the negative part of the secondary winding. So the output voltage waveform shape is sine shape. During negative half cycle, the input voltage waveform shape we have considered as a negative part of the input sine voltage. So during that time, the lower part of the secondary winding act as potential, positive potential, and the upper terminal as having negative potential. Due to that, your diode D4 and D3 are in forward bias condition, remaining 2 diodes in reverse bias condition. So this, due to this positive potential, diode D4 will be in forward bias condition. Current flows through D4 and the load and the D3, and it comes to the negative potential of the secondary winding. That it acts as a closed switch, that is diode D4 and D3. So current flows from the diode D4 through the load and diode D3, and it comes to the secondary terminal of the secondary winding. So the output voltage waveform shape was sine shape for the period of T by 2 to T. So this time diode D3 D4 conducts. Okay, during positive half cycle diode D1 D2 conducts. Okay, so this is during positive half cycle, the output voltage is sine shape, D1 D2 conducts. During negative half cycle, diode D3 and D4 conducts. So I have mentioned that it repeats. So full wave bridge rectifier as we can have a smooth, okay. For application side, we can go for full wave bridge rectifier. The advantages P inverse voltage is only V, and the transformer utilization factor is 0.81. Thank you.